The structure of the hormone testosterone is shown below. How many chiral centers does testosterone contain? So if we are looking for chiral centers or chiral carbons, we are looking for carbon atoms with bonds to 4 different groups. And we do that because that makes that carbon asymmetric. Okay, and so when we say different, it's sometimes confusing because we might say, okay, well, we've got 2 bonds to carbon atoms, so those are the same. But we want to make sure that they are completely the same. So you would have to have some symmetry in your molecule. Okay, and so also if you have bonds to 4 different groups, that means you have to have 4 single bonds. So we are specifically looking for sp3 carbon atoms. So there are some strategies that we can take. There are a lot of carbon atoms in testosterone. We don't want to look at them all. So the first thing that we can do is we can eliminate any carbon atoms that are not sp3. So we're going to eliminate sp or sp2 carbon atoms. So that's the first thing that I would do is I would eliminate these sp2 centers from consideration. And then the next thing that I would notice is that they have to be 4 different groups. So this means that I can eliminate anything where I obviously have more than one of the same group. And so where that's obvious is if you have a methyl group or a methylene group. So I'm going to eliminate any CH3s, methyl groups, or methylene groups, CH2s, because they have more than one hydrogen and those hydrogens are not different. So anywhere where I can see those obvious CH2s or CH3s, so I'll start with these CH3s and cross them out. And then anywhere where I just see 2 bonds, right, that means it's a CH2, so I'm crossing out all of the CH2s. And so what I should be left with are carbons that have 4 bonds that could be different. And in the case of this molecule, there is no plane of symmetry. So every single one of these carbons that I have left should be a chiral carbon, because for 2 groups to be the same, there would have to be a plane of symmetry. So we see 1, 2, 3, 4, 5, 6. So there are 6 chiral centers in testosterone.